Welcome. Up to here we have solved problem number 1, 6, 7, now 11 also has been solved. Now 12. An Astro Note on a distant planet wants to determine its acceleration due to gravity. The astronaut throws a rock straight upward with a velocity of positive 15 meters per second and measures a time of 20 seconds before the rock returns to his hand. What is the acceleration, magnitude, and direction due to gravity of... Let's solve it. Let's draw first this situation. Suppose this is the hand of our astronaut. He or she flows and the stone returns back to his hands here. Now we use this formula, height equal ut negative jt square. We have to find this j, this gravity. Let's solve for it now. H. Let's solve for it now. H negative ut equal negative over 2 jt square. Let's solve for j. Here we find 8 negative ut equal negative jt square. Now solving for j, always h negative ut over t square equal negative jt. Now I'm surely here. Now remember, as the object or the stone returns back to the rest point, they mean height equals 0. As height equals 0 at that point, rewrite this equation to height equals 0 negative t over t square. Now let's find good, no mistake here. Now white equal negative j. I'll have negative 2 u t over 2 square equal negative j. Now we have negative 2u over t equal negative j. Now let's find j equal to u t and u are given our problem 12. T equal 20, velocity equal 15. Now we get 2 times 15 over 20. We get 30 over 20. 3 over 2, 1.5 meter over s per second square. Now let's solve problem 13. A hot air balloon is rising upward with a constant speed of 2.5 meter per second. When the balloon is 3 meters above the ground, the balloonist accidentally drops a compass over the side of the balloon. How much time elapses before the compass hits the ground? Now let's continue. Here we use this formula here. Which one? Let's use this. Because we are asked to find this time t here. We have u, we have h, we have. Notice that our positive direction is upward, vertically upward. These are positive direction. But the object is descending. This means h equal negative over 2j t square. As my object is in the opposite direction, let's write negative h equal ut of negative over 2j t. Solving this quadratic equation in t, we have 0 equal positive h positive ut negative over j t square. Here a equal negative over 2j, b equal u, and c equal positive h. Using a quadratic equation, we find the two value of t. We find two value t1 equal negative u positive positive u square negative 4 negative 1 2 j h over 2 j. Now find negative u plus u square 2j8 over negative j. Now t2 will be equal to negative u negative this expression in root 2j over negative j, and we find here u positive, this value here ut positive to jh over j. We have to keep the positive root because it have a physical meaning. Now let's pull have negative 2.5 as in a problem. Let me see in a problem the given data, given. Now here we have speed 2.5 and the height is 3. Now replacing in our quadratic roots, we find the required result. Now let's find positive so u 2.5 square plus 2.5. Let me show you. Now we have 6 times 8.8 over negative 8.8. We get solving, we get negative 2.5 plus 8.1 over negative 0.8. Now we get let's solve 0.5 second, which is negative. Now here we will find the positive value, because see here we'll find positive value. We find negative 2.5, negative 8.1 over negative 9.8, which is equal to 2.581 over 9.8. You get 1.08 seconds. Now our object will take 1 minute. It will take 1 second. Yeah. How much time elapses before the compass hits the ground? How much time elapses before the compass hits the ground? We find 1.08 seconds to hit the ground. Here, the answer is this. The idea is simple. You have only to solve this equation. This one. We only solve this equation. This. By solving this equation for t. Solving for t, you get two value. You will discard the negative roots of value. Now, dear friends, let's problem. So it's problem 12 is already solved, and this is 13. This 13 is solved. Now In the next video, we will solve problem 14. Next video, we solve problem 14. Thank you for watching, dear friends.